Okay, here I am. I've been gone for a little while. I've been in the middle of a job transition. I'm starting to get settled in my new job now. Sorry it's been so long since I've been on here. Somebody asked a question here a while back about programming a encoder or a high-speed counter, or I think he said encoder. So you usually use a high-speed counter on anyways, or I have is encoders for measuring distances and for operation of shears and cutting materials to length and stuff. Unfortunately, my encoders that I have are throwaways from my old job. I didn't realize it, but I've only got one channel working on them. The best encoder I could find only had channel A working, so unfortunately, I'm not going to be able to show you how to do a two-phase up and down, to where you actually have basically four different pulses: pulse up, pulse down, pulse up, pulse down on two different channels. So I'm going to start with a simple one. If I can scratch up another encoder somewhere that actually has channel B, then I'll do another video on that. But hopefully you could figure this out as far as the up and downs with the manual if I give you a little basic guidance on a single channel encoder. Topo Chicos are good. Okay, but anyways, let's get into it. I'm going to show you some of the stuff in the manual here first. This is the manual. This is actually this manual's downloadable. It's just the MicroSmart FC6A series MicroSmart User's Manual. Okay, there is a section called High Speed Counter right there. Take me a high speed counter. There we go. Okay, and it kind of gives you a little application example. It's got a thing on a paper roll, punching some holes and blah, blah, blah. But I'm not going to go through all of that. I'm going to show you a simple single counter, counts in one direction. If I can find or fix, or somebody I know gives me another encoder that's any good that's got a channel B, I'll show you how to do reversibles and all that stuff. It's not that hard either. And I'll probably run on another encoder somewhere. I don't know. I'm not going to buy one. They're about $400, so there's no way I'm buying one. But anyway, we'll get to that hopefully before too long. So I know a lot of people that are in business that do a lot of cutting and shearing and measuring and hole punching and stuff like that, and they use encoders. And I'm not going to go through a whole bunch of stuff right now on encoders, how they work. Not a lot, but pretty much I'm using an optical encoder. It has a daisy wheel inside it with little bitty teeny tiny slots and a light shining through there to an optoreceptor. When that optoreceptor sees that light, it sends a signal output back to the PLC, and it does it really, really fast. And in this case, that's off. This is when it sees the light, and that's on. That's the rising edge of it. I'll show you real quick. If you were counting two pulses, two edge is what they call it in IDEC. You're counting the up and you're counting the down. So basically, you're counting the rising edge and the falling edge of that signal. If I had the other channel, I could show you there. You can do it 4 times. You're counting rising edge, falling edge of A, rising edge, falling edge of B, and the B phase is how you have to have it for it to know which direction it's going, or as far as I know, anyways. Like I say, I'm not an engineer, but the only way I've ever programmed them to where I could see which direction it's going is if I had A and B, which I do not on these encoders. Like I said, I have a channel bad for some reason. I haven't dug into it a whole lot. Some of this stuff right here, your preset value, I'm going to explain some of that. Preset value is where you want it to cut or where you want it to make an output come on. Let me put it that way, whether it's a cut or a punch or whatever you're trying to do, or maybe you want the machine to stop and then shear. There's all kinds of ways. There's different ways to do it, and when you get into all that, you're going to have to take into effect the mechanics of the machine. Whether it's stopping the shear or doing it on fly, or you have a carriage that has a boost on it. But anyways, I don't want to get into all that. That's a different animal. But I can later, if somebody asks, they want to know how to do it, I can get in there and show you some stuff on that. Anyway, preset values right here, group 1. We're going to do group 1, which is your input 0, input 1. If we were using B phase, you'd be using input 1, I'm saying, and we're going to use input 2 is going to be reset. You know, they're same all in one pretty much. I guess this one doesn't have the group 3 and 4, but we're only gonna be messing with group 1 anyway. Group 1 and 2. Okay, we'll get down here. I'm gonna show you. There's a chart down here somewhere that shows you all of the other stuff. This is a very important chart you want to know about. Right here. See, I've highlighted this chart for my own use. Okay, this gate input, let's explain that first. This M8031, whatever you have, if you want to use a special internal memory bit to turn it on, or if you have a switch on the machine that turns it on, or whatever, this has to be on or it is not counting. If this M8031 is not set to 1, it is not on, it is not, your encoder is not counting. So remember that, you have to have that. Okay, reset input, that is basically a bit that turns on if you're using an outside reset, which would be I2. That will turn on when you hit your I2. Reset status, I'm not going to get into all that. That's where it's at. Overflow, underflow, I'm not going to get into all that either. Directions, if you had A and B, it'd tell you forward or reverse. Group, all right, the current value, upper word, 8210 and 8211. That is what your encoder is at right now when it is counting. And I'll show you how to get to those two in a minute. Preset value, this is what you want your encoder to count at. Okay, and then shear. Reset value, upper word, or not upper word, reset value. This is when you hit reset, the number that you want the counter to start counting from again. So you can adjust it. It don't have to be 0. You can make it count from 10 if you want. If you know, whatever. Like I said, the gate input turns the count on and off. The high-speed counter can be started or stopped per group by turning off the gate input on or off. And it's a different one for each group. Current value, all this stuff's just kind of restated down here. Current value, pretty much it. Reset values. Anyways, we'll come back to this, and I'll show you this with program. Let's program some stuff in here. Oops, sorry. Okay, like I said, I'm just using an optical encoder. It's actually an ACU encoder. 600 PPR, which means pulse per revolution. You get into encoders, you're going to have to take those numbers and use them for resolution and turn them into a length measurement. That is how many pulses this encoder puts out in one complete resolution is 600 pulses per channel. So if you're using rising edge, falling edge, now you're getting 1,200 pulses. Or you're still getting pulses, but you're getting 1,200 counts per channel. So, which makes 2,400 counts total per resolution if you use up and down counting on A and B. So you can get a lot of, and you can think about a 3.1416 diameter wheel on an encoder, which is a foot diameter pretty much. That 1 foot cut into 2,400 pieces is pretty damn accurate. Where it's pretty finite. I'm saying that because you really don't, for a lot of applications you're using an encoder for, basic programming, you don't really need that much resolution. I mean, you can, it's fun to play with, but you cut 12 inches into 600 pieces, that's pretty good. just keep that in mind when you're programming something. Okay, so we want to program, I have an FC6A here, that's what I always use, that's what I have. Hopefully I get to save some money up and I can go back to the IDEC class before long, and maybe I can get me some new equipment, I'm hoping. Okay, anyway, configuration. First thing we want to do, I have my encoder tied, wired in to inputs 0 and input 1, okay? And my input 2 is going to be my reset. Okay, so I want to go right here. This is my group 1. I'm going to use group 1 just like it shows. Group 1, okay? See group number 1. So you'd pick this by the group. You need to make sure you use the numbers in here as you're setting up your program. So remember that. But group 1, I'm going to go to 2/ single phase high speed counter. It's going to pop up this box to where I can change stuff around. I'm just going to use a single counter. I'm going to use just an adding counter. Comparison action, none. I'm not going to use a comparison action. If I want to compare something, usually I'll just set up a compare in the program to do it. And I'll show you what that is. And you can control a lot of stuff with just this dialog box here, but I kind of like to do a lot of it in the program itself. But if you're trying to do something really finite, though, you do want to do it in here, because this runs, another thing, a high-speed counter, it runs kind of in behind your ladder logic. So no matter where your scan is inside of your ladder logic, something to note, your high-speed counter is counting in behind that. It does not care about your ladder logic. It's counting anyways. And if you set this up as a comparison in here, by putting a comparison output like that and setting your comparisons in here, this is going to fire no matter what happens. Once this thing gets to a number, it doesn't care where the ladder is, and the scan is inside the ladder. Also, you could make it interrupt also. So kind of the same thing, you can make it go to an interrupt program, which does the same thing. It bypasses the scan and it doesn't care pretty much what where your ladder is. Anyways, just for simplicity right now, I'm going to do it like this. Okay, use a high-speed counter reset input. That just means I'm going to use I2. I'm going to go ahead and check that. If I'm not using I2, you can make it reset through an internal relay, through M0832. Okay, but I'm going to use an actual I2. Okay, anyway, see, I have all this set up how it is, so that's pretty simple. Okay, now I'm going to go okay. All right, so you have to do some things, and there's lots of stuff, different things you can do, how you can get the number in there. If you have an HMI, you could make the number go in through the HMI or whatever, but we're going to do it like this. I'm going to put in an initialize bit in, enter. You know what, I think I'm going to go ahead and put this on I'll put this move. Oops, sorry, my bad. We'll put it on I3. Let's put it I7. I have a switch on my PLC. It's I7. I'm going to put this start count. All right. So now I need an output. All right. Remember down here, that gate input, we have to have that M8031. So I'm going to do M8031. Okay. So now when I turn on this switch, I7, it's going to let that counter start counting. Okay. So let's say, and then we'll do like a, let's see, I can do I mean, you can do this all kinds of different ways. I'm just showing you some stuff to do here. I3, we'll say I3, and I'm going to put move set point. Like I say, you can pull this stuff out of an HMI. There's all kinds of different ways you can do. If y'all really want me to get into that with an HMI, I can later too. That's not that big a deal. So I'm going to use my I3 is pretty much going to move. All right, so I'm going to go ahead and set it like it's coming from an HMI. Like say I have a number input on HMI. Let's see, D0. All right. Oop. Sorry. So I want to move D0. We'll call this an HMI input. Okay, so this is going to be my set point. All right, we want to move it to our preset value to 8212, not 82. If you put it in 8212, it's going to go to 8213 also. It uses two two words there. So I'm gonna go D8212. Oop. All right, so now whatever's in D0, when I hit that switch, is going to go to D8212. Let's see where we're at so far. Let's go ahead and do a save. We'll save encoder. Save it on my desktop. Whoa. Okay, let's go into a monitor. Oh, wait, hang on. Let's don't go into a monitor yet because I did not put it into the PLC. Let's put it into the PLC first. Here, let me do that a little different. I did something tricky on y'all. Y'all didn't understand. Y'all won't understand probably. I went up here. That's a quick button. Same thing as here. Let's plug this program in. It's not going to work unless I put it in the PLC. Okay, and if you did something wrong, it's going to throw you that little message down here and yell at you and say you did something wrong. If you get that, you know you don't have a complete PLC program. All right, so now let's go to monitor. All right, so you have a 1000 in there. That's because I had something in there earlier. You can do that to clear data, just so you know you can play around with stuff. You can clear data. All right, so I want to go. Let's go to a custom monitor. I want to put D0, enter, right, and we're going to see what some of this stuff here is doing. Let's go down here. I'm going to get some stuff up on this page so you can see what's going on. All right, so we want to watch the current values, 8210, 8211. You're only going to see a number in 8211, see 30. You're not going to see anything, and that's the encoder. See it move? I'm physically spinning the encoder back and forth. Now this is just an adding, so it doesn't matter if I go forward or backwards. I'm going back and forth with it and still adding the numbers up. That is coming directly off of your A channel, off of input 0. And like I say, I don't have anything. If I were to have something on B, it would be counting it right there, but you would change it in the actual the dialog box we did earlier. All right, preset value, we're going to look at that, 8212 and 8213. We'll put that in there. D. Oop. Okay, there's our preset value. So right now our preset value is setting at 1000. See, 1000. So that matches up. All right, and we're going to put, when we put a number, I'm going to show you this. Watch this. All right, D0. Pretend this is coming from the HMI. All right, so I have 500 in D0, but it's not an 8212 yet because this has not come on. So I'll reach over here and I'm going to hit my input. See, I fired that. When I fired that input, it moved that number. Okay, so say I want 1500 in there. There's all kinds of different ways you can get this to move in there. I'm just kind of showing you some stuff. See, it moved when I put it in. Okay. Now, if you wanted to fire something off of directly a compare from here, just to keep this short, I'm going to tell you what you would do. You see this number that's counting up right here from 8210, 8211? We put you a compare function in here. Source 1, source 2, you want to compare whatever your set point is you want it to fire at to that 8210, and then destination is going to be Q0 or whatever. That's what it's going to turn on. Basically, if that makes sense, you're going to compare. Let me go back to it. I should have saved that monitor, but I didn't do it. I'll show you how to do that real quick too. D0 is our HMI input. D. Okay, so when this number hits a certain number, it is going to do the compare and turn on whatever you're trying to turn on. All right, see, now I have this set to I2 is my reset. So see, when I hit my I2, hang on, I'm going to make it so you can see I2 here. Don't forget about these little boxes here too. You have all your choices of different kinds of data. If you're going to have an input that's a digital input, make sure you change it to a binary bit. So you see what's going on. Okay, see the counter's going up, and I have my I2. Say I have a relay, or not a relay, a photo sensor or something on the bottom of the shear that tells me when the shear is complete, and that's what I want to reset the count. So when that shear complete hits, bam, it resets it to 0 and it starts counting again. The shear goes down, shear complete, starts counting again. Shear goes down, shear complete, it starts counting again. Okay, well that's it for this video until I can come up with some more hardware to try to help y'all out a little more. I hope this was a good help for somebody. I can get a little more in depth with it. Let me see what I can do about getting another encoder, and then we'll go from there with it. I'll try to get another video out before too long. And thanks for watching. Like and subscribe and tell all your friends.